I hope you understand then this proportional controller. What is the proportional controller effect without and with, before controller and after controller? I think you can easily understand. Okay. Now students, then what we can understand from these particular points. Okay. So if you observe here, so I will just give a few points. Okay. Now what is the first point? The proportional controller change the transient, the proportional controller change the transient response as per the user requirement. Is it right or not? The proportional controller will change the transient response as per the user requirement. And the second point, if you observe here, what is the second point? The second point is, now omega n and kp relation. What is omega n and kp? Is directly proportional. What is omega n and kp? Is directly proportional. Is it right or not? So as kp increases, omega n is also increases. See here, when kp is 25, omega n is 5. When kp is 100, omega n is 10. Is it right or not? Now students, you just observe here. Kp is directly proportional to omega n, means as kp increases, omega n increases. Okay. When omega n increases means what? As the frequency of oscillations are increases, means as kp increases, omega n increases, system becomes oscillatory nature. System produces more oscillations. Now more oscillations, or we may call it as oscillatory nature. Oscillatory nature is not good for the system. It will continuously generate the oscillations, which means it is a less stable. Okay. So it is continuously generate the oscillation, means less stable. Okay. And I will clarify the this particular point also. Okay. Now see here. So now if you observe, as kp increases, omega n increases. As kp increases, what about the damping factor? See here. Here kp is 25, damping factor is 1. Here kp is 100, damping factor is 0.5. Means what? Now as kp and zeta is inversely proportional. Am I right or not? So now the third point what I want to say is, as kp inversely proportional to damping factor. So as kp increases, damping factor is decreases. As damping factor zeta decreases, is an advantage. As damping factor zeta is decreases, is an advantage or disadvantage, students? You just see here. When damping factor decreases means, let us assume damping factor zeta equal to 0. Now what is the peak overshoot? The peak overshoot is nothing but e power minus zeta n pi by square root of 1 minus zeta square. Let us assume zeta equal to 0. Peak overshoot is how much? E power 0, which means that 100%. For example, see here. When damping factor zeta is 0, peak overshoot is 100%. When peak overshoot is more means, when peak overshoot is more, error is more. When error is more, system becomes less stable. And I am already saying that the best system characteristics is nothing but smallest rise time, smallest settling time, smallest error, minimum error, and least peak overshoot, minimum peak overshoot. But what is the peak overshoot you are getting here? Peak overshoot is more, 100%. As damping factor data decreases, peak overshoot is increases. When peak or should is increases, peak or should is more means system becomes less stable. When peak or should is more, system becomes less stable. System becomes less stable. Understand or not? Now students, now these are the very, very important points when you come with P controller. Okay. So sir, then all these are the characteristics you observed from this. Okay. Now what I want to say is, so what is the disadvantage from here? So now that I lost a disadvantage, what I want to say is, the disadvantage is the P controller, the proportional controller cannot eliminate the complete error. The proportional controller cannot eliminate the complete error. Okay. So you just recollect what you have studied. The P controller is change the transient response as per the user requirement. You want overdamp, it will give. You want critical damp, it will give. You want underdamp, it will give. But as Kp and omega n is directly proportional, so when Kp increases, omega n increases. When omega n increases, frequency of oscillations increases. A frequency of oscillations increases, it becomes more oscillatory in nature. So more oscillations means less stable. So that is the reason why here, see here, it is less stable. So, and Kp and zeta is inversely proportional. As Kp increases, zeta is decreases. When zeta is decreases and peak or should is increases, system becomes less stable. Peak or should increases means errors are increases. When errors increases means system becomes less stable. That's why the P controller cannot eliminate the complete error is the disadvantages of the P controller. Understand or not? Okay, you just note down this advantages and disadvantages of the P controller. Okay, then students, you understand this is the P controller and what is the important and role of that P controller. So that is the reason why I am studying. We are studying without that controller and with that controller, such that you can easily understand the behavior of that controller, and in the presence of the controller, how the system is actually work. So here, this is a practical circuit of P controller. See, now this is the controller part. Now this is actually, this input is connected to the inverting terminal. So therefore this is actually minus R2 by R1, right? Minus R2 by R1. So to avoid that minus, so I just connected, this is the inverter circuit, right? R by R minus R by R is nothing but minus 1. This is minus 1. This total answer is minus 1, and here this minus and that minus is cancelled. Okay. So to compensate that minus, I will just take here. So this is nothing but inverter, because this resultant value is minus 1. This is the inverter circuit, and this part is nothing but controller. This part is nothing but controller. Sir, how I can say, sir? You tell me. This is a minus R2 by R1. Don't take minus. Here minus 1 minus is cancelled. So now this is nothing but R2 by R1. But this is a P controller, because what is a proportional controller? The proportional controller will produce a gain of Kp. Therefore, this is a Kp, which is nothing but R2 by R1. Okay. This is the practical circuit. This is practical. I am explaining generally. This is the practical circuit of P controller, and which is 100% match. So some of you are having doubt that, sir, how this Kp is changing. Some of you are saying, sir, 25, 50, 100. How, sir? How it is possible? How it will be varied? By varying this circuit elements R1 and R2 in a proper changing the R1 and R2 value in order to get the different Kps, and different Kps will give the different transient response. Okay. This is the practical circuit of P controller. This is the controller part, and this is the inverter part. Okay. No doubt, students. Okay. So this is the way we studied the all the controllers. Okay. First we will see without controller. If there is no controller, only plant, how the plant behavior. Okay. Now this is the plant behavior. The plant behavior is already available without controller. Okay. So now we will see with controller what happen. Okay. Now we'll check. Now I am taking another controller. Now I am taking I controller. Which controller? I controller or integral controller. Which controller? Integral controller. Now see here. Here the controlling actions. Here the controlling actions. Here the controlling actions are proportional to integral of the error signal. Integral of the error signal. Here the controlling actions are proportional to integral of the error signal. Now that's why this controller is also called as reset controller. Is also called as reset controller. Is also called as reset controller. Understand not? So this is reset controller, which means that integration x is x square by 2, integration of x square is x cube by 3. Always it is resetting. So this is the reset controller. So now you again controlling actions represented by P of t, integral of error signal is represented by E of t. Therefore, if you apply the Laplace transformation, now what is the Laplace transformation of P of t? P of s. Now what is the Laplace transformation of integration 1 by s? Laplace transformation of E of t is E of s. So if I remove this proportionality, we will put a constant. Now this is a constant in the integral controller. This is represented by Ki. This is represented by Ki. Now which is nothing but integral controller constant. This is the integral controller constant or gain in the integral controller. Now see here, what is I controller transfer function? Now the I controller transfer function, Laplace transformation of output by Laplace transformation of input, is nothing but a controller transfer function, which is nothing but Ki by S. So the integer controller will produce one pole at origin. Okay, note down. First, this is I controller. Now we will see with I controller and without I controller.